All right, let's start with the Monostable 555. What I plan to do is just a little intro here to what the Monostable does and what it can do for us, and a couple examples, and then we'll do a quick calculation of the pulse, and that will end this video. The next video will be a demonstration of an actual monostable. All right, so another name for a monostable, remember mono being one, is called a one-shot. So basically what that does for us, if we have our 555 timer and we have our output, which is on pin 3 of course, how we set it up with our discrete components, a monostable gives us a one-shot pulse. Now that one-shot pulse comes from a trigger, which is on pin 2. I'll do a little circuit for that in just a minute. So when this pin 2 is triggered, meaning it sees, in this case, a negative or a low, then pin 3 sends out this one-shot pulse. So what can this be used for? Well, if maybe you have an alarm system and something over here gets tripped and then triggers pin 2, you can have a light maybe that goes on, or you can have a buzzer that just buzzes for this particular amount of time. It turns it on and then turns it back off. I had a student some years ago that did a project where instead of a short little pulse, he actually created one that was very long. And what he did was, he had an issue with his sister leaving a curling iron on in the bathroom. It was a fire hazard. I guess it was an older one that didn't turn off automatically or something like that. So what he did is he hooked it up to this monostable circuit. So when she turned it on, it got triggered, which then sent this pulse out, and what this pulse did was turn on the curling iron, and he made this 10 minutes long. So literally, the iron would stay on for 10 minutes, and then it would turn off. Well, she was done well within that time, and if her sister just set it down and walked away after 10 minutes, it would automatically shut off. So that was just a project that a student did some years ago. It was kind of cool. Now, what we need to do is figure out how do we get this 10 minutes and how do we get this time. So let's go up a little bit. First thing we need to do is understand how to trigger the 555. I'm going to redraw it down here. So if this is our 555, and let's say this is just pin 2. Now again, pin 2 is our trigger. So when pin 2 sees a low, it's active low. We've talked about that before. So when that pin goes low, that means that's going to trigger. So what we want to do is we want to put a switch, in our case, to ground. So when we close that switch, we'll get a ground here. But on this side, remember, we need to hold it up to positive. So right now, pin 2 is high. Being pulled, we can use a 10K here through a 10K resistor. And then as soon as we close this switch, then we go from the high to the low because now we're grounding it. This will trigger and send out on pin 3 whatever we want. In this case, whatever was up there. Okay? Now, the other thing that we have to figure out is how long do we want that pulse to go for? Now, there are, if you look at the circuit in the spec, there is a R and a C, and it kind of looks something like this. I believe it's pin 6 and 7. You have a resistor that's connected to pin 6 and 7, and then you have a electrolytic capacitor here. Okay? And that's your R and that's your C. And then I already told you the equation is T equals 1.1 times R times C. So let's do an example. Let's say we want a pulse that's 5 seconds long. And I told you we always go into the cabinet and see what our capacitors we have. We're going to use a 100 microfarad capacitor. So now all I have to do is solve for R. If I solve for R, I will have R equal to T divided by 1.1 times C. Now if I put in my 5 for my T and my 100 microfarad for my C, I'm going to get about 45. I'm going to round it to 45 kiloohms. Okay? So, with that resistor here and that capacitance here, and then the other circuitry that we'll talk about when we do a demonstration, we would then get a pulse. Let's say this is pin 3 here. We would get a pulse that would look like this once it got triggered, and it would be 5 seconds long. Okay? One other thing I want to mention, on these, we have pin 8, and pin 8 is power. We also have pin 4. We're always going to tie pin 4. That's not writing very well. We're going to tie pin 4 to power all the time for the monostable. We're going to hold that high, because if we hold it high, then we're never going to reset. Remember, pin 4 is the reset. We have a couple other pins that we'll talk about. One is the ground, of course, and 5 is the other one. So this is what it looks like. Monostable is a one-shot. It gives us a single pulse of whatever duration that we want it to be. We can make it as long or as short as we want using this equation here. It's important to get our trigger mechanism right. Pin 2 has to see a low in order to trigger and to send out this pulse on pin 3. All right, what we're going to do next, I'm going to actually do a demonstration using the online multisim.